All right, guys, listen, this was thrown back in my lap just literally 10 minutes ago. I had no idea what was going on with this car. This is a 2008 Chevy Cobalt. I did a part 1 to this that I haven't even edited yet. I don't even remember everything that I went through. Let me give you a real quick overview of what happened with this car. This is the second engine that was put in this, and I can't show you the grounds that are underneath. They're like down in this area. The computer grounds were connected to the battery positive post of the starter. And that was among other things that was done to it. And so after they restored the connections on the car, I went through, and it was a no start, it was a no crank, no communication, and so on. So the first thing is, I want you guys to listen to it. Can one of you guys crank that for me? It does crank now. Somebody's smaller than Ricky. He's giant. He's not going to fit in that car.
You're on the corner.
You're closest, Scott. You're up. So listen, I just want you to hear, the crank circuit of this car. Okay, shut it off. I didn't know that it ran at all. Did you hear how that cranked too? It sounded horrible. It sounded horrible. But anyway, the car actually starts and runs. I was just told that the car doesn't start and it's back in my lap. But here's the first thing. The ignition crank circuit, leave the key on, Scott. You can stay in there, that's fine. The ignition crank circuit of this car is computer controlled. The computer controls, and you can watch the part 1 to catch up on this, the computer controls the starter relay on this. I left off my part 1 video going through reference circuits, going through a no crank. It didn't crank on its own. Going through a no communication, and I was walking through the reference circuit, and what we suspected in part 1 is that we needed a computer. Where I started just a second ago before we started filming here is some of my preliminary checks. Can you guys see that voltmeter number? Can you see that? Yeah. All right, so just a real quick recheck of some of the components. What I went after was the drive-by-wire throttle body, knowing that I should have a reference voltage on this circuit. I was showing in my part 1 video that I didn't have a reference. Let me find it for you and show it to you. Is the key on? Turn the headlights back off. Let me find my reference wire. It would help if my meter had a good ground, wouldn't it? Let's make sure that my meter works. 12.4. The key is on, correct? Yep. There's 441 on that one. I know I had a steady 5 on one of these. 487. There's my 5 volt. All right. So I'll just leave that sit there. I'm measuring a reference circuit. When we get to this in this class, we haven't yet, guys. This is one of the sections I have listed in my book. It's the 5 volt reference circuit. Think about this as the lifeblood of this engine management system. And in my part 1 video, I had low reference voltage. The reason the car wouldn't start, the reason the car wouldn't crank, the reason it wouldn't communicate is the reference voltage circuit was low, and I was in the process of calling a bad computer. What I told the engine teacher is to button everything back up, put the wheels back on it, everything underneath it, so I could get it into my classroom and finish. Okay, so now this is where we are. Unfortunately, they sent it to the dealer to get the computer replaced without my final checks. Now, what this is showing me though is it was the right call. We did have a faulty engine computer, and you guys will benefit from watching the part 1 at this point to where we are. This reference voltage was missing. The car didn't crank. Is the car cranking now? Yes, it is. Is my reference voltage back? Yes, it is. And so the right call was the computer. Now, that computer was damaged by grounds that were incorrectly installed, okay? And those grounds were installed on the battery positive terminal of the starter. Computers don't like power on the ground, apparently. Anyway, it was the right call, but now the car is back, and I was just told that it doesn't start. It cranks now, as you just heard. It starts and runs. Can we get an exhaust hose on this? Because this thing, I'm sure, is going to stink.
It is saying on the dash, engine power reduced.
Engine power reduced. There's a message on the dash that says engine power reduced, and that's probably because I just unplugged the throttle body, the drive-by-wire throttle body unit. So I probably caused that. There was one other check that I did. I want to show you guys this, and it was at the mass airflow. And when we get to section 12, guys, in my book where we talk about mass airflow systems, we're going to talk about this pull-down design circuit that GM uses on their mass airflows. I'm going to unplug this and show you my mass airflow signal wire unplugged. What are we seeing on that wire? You guys see it? 5. I just unplugged the mass airflow sensor, and that was missing as well. That's plugged in. That voltage is being manipulated there. All right, so our reference circuit's fixed. The car cranks. Now we're in part 2. You guys are with me? This is live. I have no idea what's wrong with the car. Could there be other things that was done to this car that we don't know about? What they told Dave at the dealer, because we had this towed to the dealer to have it programmed. And by the way, we just got a programming tool in the process of this, because we're done doing this. We're going to start doing our programs ourselves. We have that tool for the GMs. I don't know if we have for any of the other manufacturers yet, but it's a start. And so we'll be doing some of that. Anyway, it was taken to the dealer. It was programmed, whatever, and they said they think it's the timing chain, is what the technician told our staff here. And remember, this is a junkyard engine. It's possible. I don't know where we are, but they brought it back. Does that make sense? Is it the timing chain? Don't know. That didn't sound good when I heard that thing cranking. Let me get you a shot of the trouble codes. All right, these are the codes that we're showing. And by the way, we had no communication in part 1. Unfortunately, the way I started with this, and this is maybe a warning to you guys about unplugging components, I had the mass airflow unplugged, I had the throttle body unplugged before I even connected the scan tool to it. Is it possible that these TPS codes were set by me unplugging that throttle body? So now we're chasing trouble codes that I caused. I think we're going to ignore the TPS codes. I don't like the crank position code here, the variation not learned, and then crank sensor circuit. I don't like those codes at all. Let's go back and let me write those down real quick, just so we have them. I don't normally do this, but I'm going to this time. Do we worry about this air conditioning code, guys, for what we have right now? No.
I think this would be our first choice.
But it's a pressure sensor, low voltage. I mean, it's something to consider that there's shared circuitry, and it could be potentially, but most likely not. My crank position codes, I'm definitely worried about. So I wrote these down. 315 was variation, not learned. There's a relearn for that. And then 335 is sensor circuit. This crank variation relearn, let me go back and show you where that's at. I think it's under our functional tests. Right here, see it? Top left, crank variation learn. So what you would do for that, you have to have the car running. Apply and hold the brake pedal, start the engine at idle, and make sure you reach 158 degrees. Yeah, we can't even run the car. So are you going to be able to do a crank variation learn on this system? The answer is no. So I'm not overly concerned about that code, but what I'm going to do at this point, I'm going to clear them. I'm not worried about freeze frame data or that other stuff. It's happening right now. Our problem. anytime I clear codes, I always reread them, make sure they're gone. So of course the crank variation learn, that code came back because it hasn't been done. This is a different engine, different computer. There's a learn procedure that this computer needs to know, the characteristics of how this engine runs. So what we would call that is a hard fault. Does that make sense? And what about the AC pressure voltage being low? That's a hard fault too. Again, we'll kind of put that in the back of our mind for right now. Start that again. Looking for my crank code to come back. I thought this was a no start.
You said don't start it.
What?
You said don't try to start it, but
He said don't try to start it? Why would he say that? This thing's running great right now. I mean, you can see our crank position sensor circuit code came back. We would call this 335, I'd call that a hard fault too. Oh, hang on a second. This is the hard part of, there we go. It was running good a second ago, wasn't it? It was not running good anymore. Start that up again. You know, hold on. We should probably check that.
change oil soon.
Yeah, no, there's definitely oil on the dipstick. Go ahead, start that back up. Initial startup and run is pretty decent, isn't it? Is it low on fuel? What's the gauge reading? So we might be out of gasoline. That's possible. I don't like these crank codes. I don't think it'll let us do the variation learn. I mean, we could try it. We could start there. Hit the gas. I'm pretty sure it's not the timing chain. I don't know what you got. The gauges are not responding? Are any of your other gauges working? So just so you guys know what's going on.
All it has is the fuel gauge, the RPMs, and the miles per hour.
But RPMs are not functioning. So we have no tachometer signal. And we're running longer than we were before now. No tach. I don't like the crank sensor circuit. This one, let me click on this for a second. I'm using the scan tool for what I can instead of running to Mitchell. Going to my troubleshooter. And I'm going to look up this code. R335. Get possible faults. You guys see that? Let me read it to you because some stuff blocking it out. It says the crankshaft position circuit A, sensor A circuit, DTC sets when PCM detects no pulses from the crank sensor. If there's no pulses from the crank sensor, why is the car running? My first question. Check the signal and low reference circuits for open shorts to voltage, high resistance, crank sensor circuits shorted together. Inspect the crank sensor reluctor, wheel for physical damage, excessive play, looseness, improper install, excessive air gap, foreign material, circuit's okay, no damage, suspect failure in crank circuit or PCM. Some cars can run without a crank sensor signal, some of them cannot. I'm not sure the design on this offhand and whether or not this thing can run without the crank and it's a cam only. I know I'm thinking of a Dodge Durango 4.7, the cam design, and that Jeep we just did this term with the bad cam sensor signal, those Jeeps will run without the crank. Obviously it didn't run without the cam, but I have seen that. It's not unprecedented, but the car's actually running pretty decent right now. Let's see if we can do this relearn. Coolant's at 133. And what was our relearn? It said that we have to be at what?
136.
Turn the key off. I'm just following the procedure we have here. Key off and then back on again.
It's on.
And then apply and hold brake pedal, start engine and idle until 158. So put your foot on the brake, start the car.
Do I have to hold the clutch for that too? Or?
Well, to start the car, you'll need to.
Yeah,
but you won't have to hold the clutch in, no. Make sure the AC is off, make sure the defrost is off. And we have to make sure we're in neutral. Okay. And then we have to wait till we hit 158 degrees. What are you reading on the dash right now?
138.
138? So we'll just give this a second.
140. This is where we need to definitely.
I thought this was a no start. I'm as confused as the rest of you guys about what we're doing with this car. I do feel good. When you guys get a chance to watch the part one, you'll see where we were. I do feel comfortable with the call of the bad computer, and that was caused by someone not paying attention. When we get to our reference chapter, I believe it's section 9, I'm going to refer to this car and talk about the difference in the reference design that this car has from what other systems had. What's our temp now, Scott?
147.
147. What's our temperature at, Scott? 154, you said? 156? All right, I'm going to hit continue. It says, warning, in the next step, do not let engine over accelerate past fuel cutoff. Fuel cutoff should occur between 4,000 and 5,000 RPM. You keep your foot on the brake, okay? Hit continue. So malfunctions present or enable conditions not met. So if I have a crank code, is it not going to let me do it? Let me exit out. Let's go back to our codes menu again. You see we have this crank position sensor circuit fault. I'm going to try to clear this again. You guys with me? It may let me do it with the engine running. Sometimes it does. I know it said key on engine off, but you can see it did clear it. The 335 code is gone. Okay. Let's try the relearn again. Turn your key off. And let's wait for 5 seconds. Usually the off cycle, there's about a 5-second delay before the computer will actually shut down. Okay, turn your key back on.
On or started?
Just key in the ignition from off to on. Turn. All right, start it back up. Keep your foot on the brake pedal. And don't let go of the brake pedal. And we know we've reached that temperature. AC and blower and everything's off, right? It's not letting me do it. It says malfunctions present or enable circuit not met. Let's see if that code came back. Yes, it did. 335 is back. All right. That's going to have to be addressed. Don't you guys agree that this 335 code is where we need to go? I think it would be a good starting point. It won't let us do the variation relearn. I'm guessing it's because of that. I want to try something one more time. I want to see if I can fool it. I know I'm clearing the codes with the engine running. Let's reread them, see if that 335 is gone. The AC one's back. 335 is not. I wonder if that's occurring during a crank. So what I want to do for the relearn is not shut it off even though it tells me to. This step right here, I'm skipping it. You guys with me? Hit continue. Your foot's on the brake. Hit continue again. Just want to see if it is letting me do it now. You see what happened? That 335 was preventing this step. So accelerate engine to wide open, throttle, release throttle when fuel cut occurs. Do it. Do it. Let off. Look what we have on the screen here, guys. See the RPM says 0? We can't do this. You guys understand that the computer is not seeing an RPM signal, at least not right here. All right, here's what I'm going to do.
Stop your feet.
Engine data. I want to see if we have an RPM signal on the scan tool. Look. Up here, top left, right there. An error occurred. Thanks. Data display, engine data. Top left. Right there. What do we see? Now here's the thing. There's no way the computer is not receiving an RPM signal, okay? The car wouldn't be running if that was the case. Something else is going on with this crank circuit. I'm pretty sure the computer's seeing a crank signal. I don't know why it's setting the code. I don't know why an RPM signal isn't here, but would you guys agree with me that this is some pretty good direction? We have a crank variation learn that will not work with the trouble code, which we learn. We have, once we fold it into thinking that code wasn't there, we saw no RPM on that test. We confirm it right here. What do we see? No RPM. Looking for a data parameter that would give me cam and crank. You know how that we did that on the Jeep where we had those cam and crank state and it gave us like a count. You guys remember that? Crank count and cam counts on that Jeep we did earlier? Something's burning on this car, huh? Misfire, evap, sensor, ignition, maybe ignition data. We have a bunch of lists here we can look at. Just seeing what other data parameters I have available to me. Crank sensor, look. There's my crank. So let me ask you guys this. Is there a reason to put a scope on the crank sensor? With that, I'm saying no. That's not my first thought. It was a minute ago. Let's put a scope on the crank sensor, take a look at it. But what is that? I have a crank sensor RPM. And I got a cam too. Now ignore the up down in that. It looks like it's all over the place, right? Look at the scales. 804, 752. That's only a 50 RPM swing. Snap the throttle once. All right, so can we now ignore the up down in that quote hash in that signal? It's a self-updating min-max scale. Don't sweat that. Reference, just kind of looking at data here.
Safe to say that that's not seeing RPMs and stuff because of
Is it safe to say what?
Is it safe to say the computer's not seeing RPMs because the tach's not working?
Well, the tach's not seeing the RPM either. And under that one data list, we weren't, but on this one we are. See, I don't know enough about the communication network on this car yet to answer that question on where our break is or where our problem is. Is it possible that some other modules got cooked in the process of this with these wires being connected up incorrectly? I think it's absolutely possible. I'm not going in that direction yet. Yeah, see, look at our engine speed. I mean, how can you have an engine speed of 0 with a crank sensor RPM of 700? Your crank is your RPM signal. I need to know where this data PID's coming from, this engine speed data PID. And maybe it would help to look at the wiring diagram again and look at this crank sensor circuit. Let's do that together. Shut that off. I'll leave this roll. Turn your key back on. We'll come over here. I don't know about you guys, but stuff like this is actually fun. I like detective type work. We just did one, right? Ignition switch. That was fun, going through that circuit. This is fun. I know, Dom, you think I'm crazy, but this is actually kind of fun. It can be confusing when you're new at doing this, but you know, the more you see it, the better you're going to get at it, and you'll have direction as you continue in this field.
Phone now. I'm not on my phone.
He's not actually. He's paying attention. He's not on his phone. It's great.
Show us the Coley. Actually, here's the call.
All right, look, I do have some X's and stuff in here. This is when I was checking the reference circuit. What I have in blue here that's already mapped out was my reference. You see it says 5 volt ref, 5 volt ref 2. This is where I was when I called the bad engine computer, or I was ready to call the bad engine computer. We need to focus right now on this crank, which is, that's cam, this is, hang on. That's the crank, that's the cam. This one to the left is the crank. Crank uses a reference circuit, and then I'm following this wire right here, goes to the computer. It says low reference, and then, man, I can't even see that one. Right here, crank sensor signal is right there. So it's a 3-wire sensor, it's a Hall effect, digital signal. And it goes, all 3 wires go to what? What is this component? My engine computer. That should be where I'm getting RPM from. Is it going to be worth checking that signal? I said no because we had a crank RPM, but could it be substituted from the cam? I don't know. We're getting a crank reference code, which according to the flowchart on the scan tool is what? Wiring sensor or computer. Isn't that pretty much our only options with the 335 code? Do you remember? What do you guys think about the diagnosis of this being a timing chain by the technician that changed the computer and programmed it? Exactly. Dom's face says it all. It's crazy, right?
Where did they take it?
Chevy dealer. I'm not going to mention that. Okay? I don't. Yeah. All right. So what? High resistance, short to voltage, crank sensor circuit. So that's wiring. The reluctor, which would be the piece that's driving the sensor. I don't know if that's on the flywheel or if that's part of the harmonic balancer. I don't know enough about the crank sensor on this. Improper install, excessive air gap, foreign material, magnetic interference. Yeah, it's basically sensor, wiring, computer, or the reluctor. That's it. Maybe it's worth looking at it. And I guess at this point what I'm getting at is I'm not sure why else we wouldn't be seeing an RPM signal.
When you guys tested it before, did you back probe?
I never tested it before. Remember, I didn't have a reference voltage.
What I was saying is when somebody's gone in there and played with the connection of the wires.
And saying that we don't have a signal now? I mean, that's for sure. I mean, anything's possible with the sensor as far as signal, but remember, I didn't look at it. This car didn't run last time I looked at it. And let's see if your key is on, right? Let's see if that code came back. I'm pretty sure that it did. Whoops. Hey, now we have a fuel trim, lean condition. We're gonna have a lot of things we're gonna be doing with this thing apparently. Can you crank that and start it again? Let's see if we get this crank code come back. Yeah, as soon as you crank it is when that code comes back. All right, something else that I need to point out. Shut this off, turn the key back on. There's something else I need to point out to you guys in round one of me looking at this car. When I got to this in the first place, and this is pretty typical. You have a no start, no crank, and of course the battery's stone dead when you get there, which is exactly what I had. In fact, it was more than a dead battery. It was loose terminals on the battery too. So after fixing the battery terminals, I tried putting a charger on this, and I had, as you see, my battery post here. The battery's in the trunk. This is a post for the fuse box. I put the ground for the charger on this housing on the valve cover, and what I found is that valve cover housing was not a ground. It uses even though it's aluminum, apparently the rubber gasket that's underneath of it is enough of an insulator that I couldn't charge the battery from the valve cover, but as soon as I moved over to this bracket, which is next to the valve cover, I was able to. And there were grounds right here, and I don't know how well that's showing up, probably not well at all. This ground eyelet, or this loop, was grounded right here on this bolt on the valve cover. Those were further grounds for some system that never had a ground. So we had to undo that as well. Where was I going with that? When we crank this thing, how much do we load grounds on a car when we crank an engine? How much amperage does the starter draw? A lot or a little? A lot. Is it possible we have another ground problem that is being stressed by the starter motor? Or do we have an actual crank position sensor circuit fault? I really think, I don't mean to be back and forth with this or flip-flop, but I want to see what that crank sensor signal looks like. What do you guys think? I think that's our next step, is to connect to this crank sensor and take a look at it, see what that signal looks like. And we can do that at the sensor, which is lower left rear of the engine. I can do that real quick. I remember the crank sensor plug. It's actually, I'll show it to you. I remember this from working on it previously, because one of the reference circuits were that paper airplane should have made its path in front of the camera. That would have been better. Hang on. The crank sensor's not plugged in.
What?
I swear, I'm not kidding. I reached out. Hold on, let me get the camera down there. So, the crank sensor's not plugged. See if this car starts, please. Okay, what do we know about the crank sensor on this car? Wait. What do we know about cam and crank on this car? Can this car run without the crank sensor?
Yeah.
Yes. Hold on. Let me shut that off. Turn the key back on. Now, this could have been left unplugged by me when I was doing my things in round one of trying to find my reference voltage, and I'm not going to fault the technician at GM for missing this. It was in the connector. It wasn't unplugged, like blatantly unplugged. It was, does that make sense? All right, I'm going to make sure we're on the right connector. The wire colors, guys, I'm reading right here. The wire colors for the crank sensor. I can't see it. Hold on. I need glasses. Looks like light, is that light brown, or I drew over it? Light green, purple, and yellow. Try to focus here, please. Light green, purple, and yellow. Is that the color of this connector? Here, guys. I'll get the camera on that. I left the connector right here, guys. It's right here. What do we see? I see light green, purple, and yellow. So guess what? That is my crank sensor. The other half of the connector, let me get you a shot down here. Let me try to get you a shot down here. There's the other half of the connector right here. You guys see it? All right. I'm going to plug this back in. Wait. Well, yeah, we'll do that. It can't be this easy. Can it?
Relax.
Can it? Start the car back up. Doesn't sound any different. Let me go back to the scan tool. This is why I like filming live sometimes. There are certain things you cannot recreate, and the certain things that you can't recreate is your surprise when you run into something, you know, and then you film it in hindsight and you have to recreate it.
It wasn't letting us do that test before.
It wasn't. We're going to redo all of this. Before we do the crank relearn, guys, we have this, right? We have our crank code, but I never cleared that. Before I do that, though, let's go back to our data display. Remember what we were questioning. And under my ignition data, let's see if we have, is your tach working right now, by the way?
No, so it's good.
I was excited. Did we ever turn the key back off and back on in the process of me plugging this back in? We never had the key back off. Let me see if our crank sensor's here. We had an RPM. Nope, our engine speed's still at 0 too. That sucks. I was excited about nothing. Maybe, I don't know. Let me clear the code. We said it couldn't be that easy. Let's redisplay them. Of course, our variation one is there. And then turn the key off. Let's wait for 5 seconds and then I'll have you restart it and we'll see if our crank code comes back. Go ahead. Got a tach that's working now?
Yep.
So tachometer is now working. So what's different with this system? It almost was like without it seeing that crank signal, it's keeping that in a default mode, which is 0. Does that make sense? This happens with computers. You see a fault in a system, certain things are shut down and ignored. It's running in a default mode. So it wasn't recognizing that crank. I didn't get a crank code back, so let's go back to that data now. We got some surging taking place now. And actually, believe it or not, the surging is telling me that this thing's running like it should be now. Remember, we have a lean code. We have to chase another problem, but timing chain, man, come on. I'm shocked that a dealer tech would tell the owner of this vehicle or us, the school, that it needs a timing chain. Check it out right here, engine speed. What do we see? Same as the crank. Snap the throttle so we can get rid of that min-max scale. Is it safe to say, guys, that the cam sensor, which is also showing us the same RPM, that the cam sensor signal was being used as the crank? You talk about scan tool data that will mess you up. We had a crank sensor RPM, didn't we? The freaking crank sensor was unplugged. That's pretty cool, isn't it? We have a tachometer that's now working. Do we have fuel trim issues? Possibly, but should we do this crank relearn now? I think it's worth trying again. Let's do it. Keep this in mind. When you do these functional tests, will it let us do the test with a code? With that crank code, it wouldn't let us. So let's follow what it says. Turn the key off. Turn the key back on in about 5 seconds. I know it doesn't say that. This is just experience. Foot's on the brake pedal, right? We know our temperature's good now. Accelerate engine. Notice we have an RPM signal here now. Accelerate engine to wide open. Release throttle when fuel cut occurs. This doesn't have fuel cut. It just limits your wide open. So go wide open, hold it there for a second, and then let off. Test complete. Wow, that was hard. Crank variation learned successful. Let's go back now to our fault codes. Oops, keep hitting that one. That code's in memory. Should we maybe clear that now? I'm gonna do this running again just because I've been. What do you guys think? Well, that was hard. Needs a timing chain, right? Come on, man. Needs a timing chain? Are you kidding me? Now, granted, did you hear the way it ran at first? And is it possible it ran that way because it didn't have a crank signal and it was trying to determine by the cam alone where our timing was on this engine, and that was why it cranked so funny and sounded so bad? Is it also possible that it never ran right for this other technician? And I don't want to throw him under the bus. I don't know who he is anyway, but is it possible that with this thing popping and banging and running like that, that he might have just, his warranty time or whatever he gets paid wasn't enough for him to dig into it, and it's more of a byproduct of our pay system than it is that he misdiagnosed it. I'm not, that's possible. Air conditioning, I'm not worried about this. You guys agree? We did have a 171 code though. Let's take a look at that, right? That 171 code, we went through this week. Which data list do we want to go to see O2s and fuel trims? What do you think? One that says fuel trim data, you think that will help? Yeah, let's do our fuel trim data. Is there other components that were left off of this car? I'm sure. Looking at, I'm going to customize this.
Shouldn't the loop status still be closed by now?
We should be closed for sure. Did it? Looking for my downstream O2, help me out right there. Just kind of, oh yeah, look at my long-term and short-term trim, guys. What kind of condition do we have? I'm sorry that's a little bit blurry for you guys. Let's do this, maybe that'll help a little bit. What's our long-term and short-term telling us? This is cool, man, because we just did this today. We have pretty much a maxed out trim, right? 55%. What kind of lean condition we have? Raise your RPM. Let's see if this improves. Hold it at 2,500 or 3 grand. Look at your long term. Let back off. And I can hear you're having a hard time holding it there.
No, I was holding it where it was and it just kept...
Right. Short term, ignore that. That's, oh no, that was the full range of that, wasn't it? That's short term moving up and down. Sometimes the computer will do that with a flat O2. But did it improve right here? Look right here. So what are we thinking when we see that? Vacuum leak. So, but here's the thing, is this car fixed from a standpoint that we now know we don't need an engine and crank sensor was the main thing, it was left unplugged, we did a crank relearn, some bonus material here. Let's find this lean condition. Let's do some quick checks under here. Why don't you guys come up and join me under here? Or unless, I mean, I could show you with the camera right here if you want to. It's, I mean, you can see what I'm doing right here, it's fine. Just try not to lean on the car or move the car. My first thought on this would be the air intake. Just trying to do things quickly. Yeah. Here. Why am I thinking air intake? Because someone was here, okay? This is not good. When you have a mass airflow system like we do, all of the air has to go through the mass airflow, including the PCV system. This is part of the PCV and it belongs into the air cleaner housing, and that will absolutely make this thing run lean. This whole housing is loose. See if I can get that back in there. Can you hold that in there while I show you the scan data?
Yeah. That's stop.
Here's what I want you guys to look at. As soon as he plugs that in, are you in there tight? Look at the O2. Look at my O2. Did it go rich? Okay, let's keep watching. You gotta hold it there tight if you can. Look at my short term. What's the number one job of the short term? keep the O2 moving back and forth across stoik. Are we watching that now? Short term's coming down. Now I realize it's tough for you to hold that, so that's part of what you're seeing in here. Do we need to fix this PCV line? Is this part of our condition? I would like to see this go way negative to say that it's absolutely fixed. Because look at our long term still at 30. Let me see if I can let me hold it there and see if I can make this darn it. Am I still in closed loop or am I in open loop? Open loop is not going to be good for what I'm trying to do here. No, we just went into closed. Hey guys, look, hold that there. Did you see the negative? It was like negative, what was that number? Negative 14 there for a second. It's this grommet for this PCV system. Back into open loop again. Let me stand there. I don't like this tube being it's all collapsed. The mass airflow tube. Why is this so?
Oh, this part's not even.
And that doesn't even reach. All right, that's good enough. All right, I'm not gonna stress about this. What needs to be corrected is this PCV line is broken going to the air cleaner housing. And then the mass airflow tube itself, the corrugated tube is like crushed underneath. So this needs to be repaired, which is part of this housing. That housing needs to be replaced before we go any further. It does not need another engine. I think we're pretty happy about that. Everybody else will be happy about that. You guys need to watch this part one, because the part one really walked you through what it takes to call a bad engine computer. And that's what it was. And these other things are variables you got to learn too. So that was actually really good. I was happy to have that. All right, I couldn't let this go, guys. Just want to get a final shot of, no, not the airplanes flying across the screen. I want to get, guys, listen, please. Just a final shot. This is the tube that we were talking about. That's our PCV line, and that goes on the front of this right here, and that metal part is broken off. But here's the other part of the lean condition. My concern, guys, was when we were blocking this off, we couldn't get the short term to go way negative, and here's why. The entire housing is broken right here. So this is air entering the system outside of the mass airflow sensor, and that makes sense. As we were leaning on this, things were changing. That housing's busted. So what we'll do is we'll replace this housing, and then I will do a final shot of the fuel trim on this just because.